Hi, this is JD, and in this video we're going to be going over measurements, statistics, and graphs, all introduction. So here's a little preview. We're going to this unit basically has three parts. It has measurement, and we're going to go over the metric system and the US system and temperature. We're also going to go over statistics, that's the second part, measures of center, and different types of graphing data. And then we're going to graph, the third part is we're going to graph lines, and we're going to go over plotting points, XY plane, and graphing lines. So part one, measurement. So here is the metric system. And with the metric system, what you can do is basically just move the decimal. So you have mega, which you're not going to see in here, but you might see it elsewhere. Kilo, that's 1,000. Hecto is 100. Deca is 10. Then you have the unit. Now the unit can be either meters, grams, or liters. Then you have a deci, that's like a 1/10. Centi is 1 out of 100, and mella is 1 out of 1,000. So, way that you can kind of remember this is by using this acronym. Mighty King Henry died by drinking chocolate milk from or at McDonald's. And you can come up with your own. This is an acronym, so it's a memory hook so that you can remember the prefix is for the metric system. Now what this means, these arrows from smaller to larger, is if I have 1 liter, and I want to move this way to a kilo, that's going to make it look smaller. Where if I have 1 liter and I want to convert it to milliliters, if I go to a decimeter, that's moving the decimal place over once. So 1 liter would be 10 deciliters, 100 centiliters, and 1,000 milliliters. It makes it look larger as you shift it. And all you're doing with the metric system is just moving that, you're just moving the decimal. Right, so let's look at some examples. Again, you can bring out the chart. Again, you can kind of ignore mega and micro for now. But again, you might see it in other classes, depending upon what program you're in. So if I want to convert 6.7 kilometers to meters, meters is a smaller unit, so it should make it look larger. So if I'm moving from kilo, that's 1, 2, 3 to units. So I'm moving the decimal place over 3 times. And so you get 6,700 meters. Now, if I wanted to move from 50 milligrams to a decagram, milligrams over here, decagram is over here, so it's 1, 2, 3, 4. I'm going to move the decimal place over 4 times. It's not necessary to put the 0 in here, but I just wanted to show you that you're moving the decimal over 4 times. Now, if I'm converting it from liters to milliliters, that is 1, 2, 3. So moving the decimal place over 3 times, and it's going to make it look larger. So it'd be 20,300 milliliters. So all you do when you're converting within the metric system is you just move the decimal place. You can do that because it's a 10-base numbering system. Makes it pretty easy. So let's talk about liquid measurements. We already talked kind of about liquid measurements when it comes to liters, but let's talk about the US system. So the US system, and this is a way that you can remember what's equal to what. This is, the G stands for gallons, Q stands for quarts, P stands for pints, and C stands for cups. So 1 gallon is made up of 4 quarts. Each quart is made up of 2 pints, and each pint is made up of 2 cups. You can also think about, when it comes to measurement, things that you have. So you have a gallon of milk or soy milk, and a gallon of milk, half of that is half a gallon, which is 2 quarts. Typically, you have, and different things come in quarts and different things come in pints. So you have like ice cream and all sorts of stuff. So all right, so when it comes to the measuring system or unit conversions, what you can do is you can multiply by a unique 1. There's also another way to do unit conversions, and that is to convert using proportions, but I like the multiplying by 1 method. So let's say that you want to take 52 pints and you want to convert that to cups. You know that there's for 1 pint, there's 2 cups. So you would take that 1, whatever you want to cancel, you would put diagonally, and whatever you want, you put out at the same level. So I put 1 pint in the denominator and 2 cups in the numerator. The pints cancel out and you're left with cups, and then you just multiply the numbers. So it's 42 times 2, which gives you 84. Now let's look at that next one. Taking 58 pints, and I'm converting that to 7 gallons. I know in 2 pints, there's 1 quart, and then in 1 gallon, there's 4 quarts. So what I can do is take the pints, 48 pints, multiply it by a 1. That is that the numerator and denominator are equal to each other, even though they look different. They're just different units of measure. So 1 quart is equal to 2 pints. I want the pints to cancel. I still want to get to gallons. So I know 1 gallon is equal to 4 quarts. Can multiply that by a 1. Again, you can't see my fingers, but I'm doing quotes. Doesn't exactly look the same, but they are the same, right? They're equal in value. So 1 gallon is equal to 4 quarts, so you can set up a ratio there. And then the pints cancel, the quarts cancel, that leaves you with gallons. And then you would just multiply across. This is 48 times 1, which is 48. And then the denominator is 2 times 4, which is 8. So that's 48 divided by 8, which I think it should be 6. Yep, that should be 6. And then the pints cancel. If I know that 1 gallon is equal to 8 pints, I can do it that way as well. So the 48 cancels with the 8, leaving you with 6, and so 6 gallons would be your answer. All right, so what about we have length in the US system, and we're going to look at some other ones as well. So this would be 5 feet, 8 inches, and you want to convert that to inches. So you just have to convert the 5 feet to inches. And you know, in 1 foot, there's 12 inches. Again, multiplying it by a 1. You know that 1 foot is equal to 12 inches, so you put the feet diagonally, and you put the inches on top. So then you would just multiply, you get 60 inches. You still have that 8 inches, so you would add 60 to 8, and you would get 68 inches. Now let's look at the 9 quarts. You know, with a quart, there's 2 pints. So you would multiply, you want the quarts to cancel, so you put that diagonally, put the pints on top, then multiply, and you get 18 pints. Now what about converting 52 inches to feet and inches? So how do you do that? So you know that there's for 1 foot, there's 12 inches. You want to put the inches diagonally and feet on top. The inches cancel, that leaves you with 52 over 12. Now what I would do next is don't simplify it, keep it over 12, because you know that 1 foot is equal to 12 inches. So divide, find the mixed number. So 12 goes into 52 4 times, with 4 left over. 4 times 12 is 48. 52 minus 48 gives you the 4. Again, don't simplify, because 4 out of 12 gives you the inches. So that would be 4 feet, 4 inches. Now here's some uncommon unit conversions when you're converting from the US to the metric or metric to the US. And I did put these conversions that you might need on the handout. All right, so if I go back, so I'm taking kilometers and I'm converting that to miles. So I can just use this right here. I know that 1 kilometer is equal to 0.62 miles. So I can multiply it by a 1, right? They're the same value. I want the kilometers to cancel, so I put that on the bottom, and I'm putting the miles on top because that's what I want on top. So then you multiply the two, and you get 68.2 miles. All right, so let's look at the next one. The next one doesn't have a straight conversion. So what I want to do is I want to convert feet to the metric system first. So we know that there for 45 feet, for 1 foot, there's 0.3 meters approximately. So I want to convert it to meters first, and then once it's in meters, I want to convert that to centimeters. Now, with 1 meter, there's 100 centimeters. Centi just means 100, but you know it's smaller, so it has more. Or you can just move it twice on that table. So 100 centimeters is the same as 1 meter. And then what you would do is the feet cancel, the meters cancel, leaving you with centimeters. So then you would just multiply across and you get 1,350 centimeters. At this point, with some of these steps, I would highly recommend a calculator. All right, what about temperature conversions? Temperature conversions are a little odd. They're different from the other types of conversions. But what you're going to do is you're going to apply a formula. So from Celsius to Fahrenheit, you have this formula, F equals 9C, C stands for the temperature in Celsius, divided by 5 plus 32. And then from Fahrenheit to Celsius, you're going to use this formula, C equals 5 parentheses 5 minus 32 all over 9. So with that first one, it's in Celsius, and you have to convert to Fahrenheit, so you would use that first formula. And it's just a matter of plugging things in. So you would plug in the 34, so it would be 9 times 34, which is, I don't know off the top of my head, divided by 5 plus 32, and you get 93.2 degrees Fahrenheit. Again, you're just using a formula. So letter B, converting Fahrenheit to Celsius, you would use that seconds formula where you have C and then you have 5 parentheses F minus 32 all over 9. So plugging in 75, you subtract, multiply the 5, and then divide by 9, and you get approximately 23.9 degrees Fahrenheit. Oh, and I say approximately because I did rounds to nearest 10. And they'll tell you how they want it rounded. All right, part 2, statistics. And we're gonna in these sections are pretty much introduction. So it's just to get your feet wet with these different types of maths. So we're gonna go over measures of center or measures of central tendency, and then we're going to look at graphing data. All right, so here's the measures of center or measures of central tendency. So you have mean, which is the same as the average. And the formula for that is the sum of the items, which means that you add up all the items and you divide the whole thing, whatever that sum is, the result, and divide that by the number of items. Now the median is the middle number. So if it's an odd number of items, you're going to have an actual middle number, so you would use that. If it's an even number of items, then you're going to take the average of the middle, which means the average of the middle too. And then mode is the most frequent item. And with mode, you can have more than one mode, or you can have no mode. No mode is the situation where all the items occur the same number of times. All right, so now let's calculate an average, or the mean. On a 4-day trip, a car was driven the following number of miles: 235, 135, 225, and 145. What was the average number of miles per day? Round to nearest mile. see if I did that. So you take the sum of the items and divide it by the number of items. So you would take the sum 235 plus 135 plus 225 plus 145. You would, if you're not able to type this whole thing in your calculator, you would add all these up first and then divide by 4. And you get 185. And you expect this to be somewhere in between the lowest value and the highest value. So keep that in mind when you're working these out. All right, so what about this type of example? To get a passing grade in math, Waldo must score an average of 76 on 5 tests, he calculated. On the first 4 tests, his scores were 75, 90, 63, and 80. What is the lowest score that Waldo can get on the last test and still pass? Interesting math question. So this is how you're going to set it up. You add all the values and then you have x because you don't know the value of the 5th test. And you're going to divide it by 5 because there's 5 tests. And the average he figured out that he needs for the class is 76. So what you do first is, looks like, yeah, you can add all these numbers up and you get 308 plus x over 5. Now you can get rid of the 5 by multiplying both sides by 5. You get 308 plus x equals 380x. Then subtract both sides by 308 and you get x equals 72. So the lowest that he can get on that test and still pass is 72. All right, what about the median? So it says, the following are the salaries of the top 4 employees of a company. What is the median of the salaries? So you have 65,000, 70,000, 55,000, and 90,000. Notice it's 4. Now, to do this, what you want to do is you want to put it in order first from least to greatest. And then we're going to do, since it's an even number, right, there's 4 of them, you're going to take the average of the middle 2, which is 65,000 and 70,000. You can calculate where the median is at by taking the number 4 and dividing it by 2, taking the number of items, dividing it by 2, and if it's even, it's going to land on a number, like here 2, and then you would use the 3rd one. If it's odd, you divide by 2, you're going to get something 0.5, you would round up, and so that next number that comes would be your median. So we're going to take the average of the 2 here since it's even. So average of 65,000 and 70,000. So I'm going to take those, add them, divide by 2, and I get 67,500. And that's it. Again, remember the median is the middle number. If you have the middle number, you would take that. But if not, like when it's odd, you're going to have to take the average of the middle 2. All right, so what about mode? Again, it says find the mode of these this data, of these data. So what you're going to do is make it a little easier. You can put them in order. So that's what I did here. And you can also count. This is 1, 2, 3. Makes it easier. 1, 2, 3, 4, 5. Looks like 3, 1, 2, 1. I would also double check by counting to see if it's the correct number. And so look at the 25. So 25 repeats 5 times. Others, maybe three times. So 25 would be your mode, right? Mode is the most frequent. Now let's look at different types of graphs. So IMS Health and the DA/CDS Economics Department have released data regarding the number of prescriptions filled in supermarkets for various years. In 1997, 269 million prescriptions were filled. In 1999, 357 million were filled. In 2001, 418 million were filled. In 2003, 462 million were filled. In 2005, 465 million were filled. And finally, in 2007, 478 million were filled. So there's different ways that you can do this. One is set up a table. Set up a table is going to be helpful also when you're setting up other graphs. So table, you have the year, and then you have the different numbers. Here's an example of a pictograph. Pictograph uses pictures to represent the data. And usually there's some sort of key that tells you what each one equals. They look fun. And then also a line graph. Line graphs are typically used to show change over time. And here you have the years and then the number of prescriptions filled. So you have different ways that you can graph the data. And this is where you have to, look at the picture, because sometimes with pictures that you find elsewhere with graphs, they kind of manipulate how it looks. So it might not be accurate or representational of the actual data. All right, so here's an example of a pictograph. The following pictograph shows the career high number of touchdowns passes in a season for 7 quarterbacks in the National Football League. Located below, I guess the next slide, is a key that tells you that each football symbol represents 10 touchdown passes. All right, so might mispronounce the names. I don't watch football that much. So, anywho. So if you look at this, it shows you John Elway, Dan Marino, Joe Montana, Roger Staubach, Tom Brady, Brett Favre, and Peyton Manning. And then it shows you the year, and these are career highs for them. And then it shows you the number of touchdown passes. And so here's some questions. And again, it's just a matter of reading. We're going to go back and forth, so it might be a little tricky. So which quarterback has the greatest number of touchdown passes? If I look at this, you have Dan Marino. There's a partial football But if I look at Tom Brady, notice that there's a entire football here. So it looks like Tom Brady is 1. Which quarterback has the least number of touchdowns? Go back. Least number of touchdowns, looking for the smallest number of touchdown passes, and it looks like it's Roger Staubach. How many more touchdown passes does Peyton Manning have in his career than John Elway? So you're comparing the two. How many more would mean that you're taking each of them and you're subtracting them, the larger value minus the smaller value. So again, if I go back, John Elway, and here you have to kind of guess a little bit. That's about 20 something, close to 30. And Peyton has about 50, but close to 50. So I just guessed on these, and I guessed around 21. All right, example number 11. Theodore Roosevelt's trip to Panama in 1904 was the first presidential foreign visit. The 42 and the 43rd presidents of the United States made more than twice as many foreign visits while in office than previous presidents. The following horizontal bar graph shows the number of foreign visits by the 34th to 43rd presidents. I would also be curious about national debt as well, and maybe executive orders. So here's the graph. You have Eisenhower, Kennedy, Johnson, Nixon, Ford, Carter, Reagan, Bush, Bush Sr., Clinton, and Bush Jr., George W. All right, so that's the bar graph, and notice that these are separate. That's because they're kind of in categories. And you can have this either horizontal or vertical, the bars. Typically with a bar graph, it's going to be vertical, but I guess for a fancier picture, made it horizontal. And then you see the number of foreign visits on the bottom. All right, so let's look at these questions. Which president in the list made the fewest foreign visits while in office? So I have to go back. Fewest visits. Looks like it's a toss-up between Ford and Kennedy. And so looks like it's Kennedy. How many foreign visits did Ronald Reagan make? With these bar graphs, it can be kind of tricky. So you have to make an approximation here. Looks like it's really close to 50, so it might be 49. 49 or 48. I want to say 49. What did I put here? 49. And which president made approximately 130 foreign visits? Go back to the table again. 130 visits. Right here, it looks like it's, you look at the 130 line, it looks like Bill Clinton. So Bill Clinton. All right, now let's look at a circle graph. And here, the circle graph, it says there are over 1.5 million children publicly supported foster care in the United States. The circle graph, or sometimes called the pie chart, shows the percentage of foster children by age. Here's it shows it by age. Sometimes there might be like a color key. Sometimes percents are given, sometimes they're not. All right, so let's look at the questions. So which age group has the most children? Going back, that would be the largest percentage, which would be 11 to 15 years of age. What percent of the children are 6 to 12 years old? Going back, 6 to, what was the question? 6 to 10. Just by reading it, it's 25%. In 2008, there were 580,000 children in foster care. How many were 16 to 18 years old? So here you're looking for the number of children, and you can figure it out because they do give you the total. So if I go back, 16 to 18, that's 16%. So 16%, you would multiply that to the total, and you get 92,800 children. Now, what percent of children in foster care are less than 11 years old? This one might be kind of tricky. So less than 11 years old would mean all ages less than 11. So that would include 10 to 6 years, that's 25. 1 to 5 years of old, that's 24, and then under 1. So what you would do is you would add up all these numbers right here, all those percents. So the 25%, the 24%, and the 4%, and you get 53%. Part 3, graphs and lines. Plotting points and graphing lines. So let's look at first plotting points. So on a graph you have an ordered pair. An ordered pair is X and Y. On the graph you have a Y-axis that goes up and down. The X-axis goes side to side. So what would be point A? So point A is over here. And so what you would do is you'd start with the origin, that's 0, 0, and you basically just see what lines up. So you can travel it so that it's going over 4 up to, and you're there at that point. So that would be 4, 2. I guess I can write that in there. So 4, 2. And then what's B? Well, again, you just see what lines up, kind of like a map. X coordinate first, which would be -3. Whoops. -3, comma, and looks like -5 for the Y. Again, you're just seeing where it lines up. Now the quadrants, I don't know if you necessarily need to know these, but the quadrants are kind of like a C shape. So you start with quadrant 1, which is this top right-hand corner, and then you go around like a C. So 1, 2, 3, 4. And that's pretty much it with an ordered pair. So let's go over like more examples with ordered pairs. So here's example number 13. And whoops. Here's example number 13. And so it reads, plot each ordered pair on the Cartesian coordinate system and name the quadrant or axis in which the point is located. So 3, -4 would be right there, right? The x is 3 and you're going down 4 at -4. You're seeing where those two line up. So what quadrant that's in is it's in quadrant 4. 0, -2, it's not going to the left or to the right. So you would just go down 2. And that's going to be on the y-axis. -2, 4, that's in that top left-hand corner. You go over 2 to the left and up 4, and you're there. And that is in the second quadrant. And then 4, 0, which is right there, would be on the x-axis. So how do you determine whether these points are solutions of the equation 4x plus y equals 8? Well, first what you would do, let me put on laser pointer again. First what you do is you just write out the equation and then you just plug in the point. X coordinate, y coordinate. So you just plug those in, replace the x with 1, replace the y with 4, and then you just see if it's true or not. So this ends up being 8 equals 8, which is true, which means yes, 1, 4 is a solution. Let's look at that next point. I'm going to rewrite the equation again. You have 0, 6, and so we're going to plug that in, x coordinate, y coordinate, so you're replacing the 0 or the x with 0, replacing the y with 6, just plug that in. End up with, that should be 10. No, wait, it is 0. So it's 4 times 0, which is 0. 0 plus 6, which is 6. That's false, so therefore it's not a solution. Should read not a solution. Is not, using my mouse here, is not a solution. All right, so let's continue. Rewriting the equation again. And this time I'm plugging in 3, -4. Replace the x and the y. So I have 4 times 3 plus -4. That's 12 minus 4, which does give me 8 equaling 8. So yes, it is a solution. So that's how you determine whether an equation or whether the points are solutions of the equation or not, is just by plugging it in. If it's true, yes, it is a solution. If it ends up being something false, it is not a solution. So example number 15, what we're going to do here is we're going to be graphing lines, and I'll show you 2 examples. So first what you want to do is you want to set up a table, x, y, and then it doesn't matter what numbers you plug in. Your goal is to get the picture. So you can plug in anything you want for x, but you're plugging into that equation. So if I'm going to take 0, plug that in, That gives me y equals negative 3 times 0 minus 2, which just gives me negative 2. Plug in 1. When I plug in 1, that's 1 times negative 3, which is negative 3. So it's negative 3 minus 2, which gives me negative 5. Again, you're just taking the x value and you're plugging it into that equation. Take 2 and I'm going to plug that in. Negative 3 times 2 is negative 8. Minus 2, sorry, 2 times negative 3 is negative 6, and then negative 6 minus 2 is negative 8. So let's plot those points. So you have 0, comma, negative 2, that's there. 1, comma, negative 5, so 1, go 1 over, down 5. And then 2, so this is 2, and then see where it lines up. That would be at negative 8. And then you only really need 2 points. 3 points are just there just to double check yourself. And then from there, you just connect the dots. All right, example number 16, and notice here I have a fraction. Since I have a fraction here, I can basically, again, for x, I can plug in any values that I want. So I'm going to set up my table again. This time, what I'm going to do is I'm going to plug in numbers that are convenient. So I know I'm going to have to divide by 2. So I'm going to plug in numbers that are divisible by 2. 0, just plug it in. Here you get 0. 0 times negative 1/2 is 0. So now I'm going to plug in a negative 2 instead of a 1. So I can get a nice number. Negative 2, when I plug it in, negative 2 times a negative 1/2 is a positive 1. When I plug in 2 into this, 2 times a negative 1/2 is going to give me a negative 1. So let's plot these points. Start with 0, 0. That's there. Negative 2, positive 1, that would be right there. I'm going over 2, up 1. And then 2, comma, negative 1, I'm going over 2 and then down 1. And then connect the dots. And that's it. So let's review. So first we went over measurement, went over the metric system, how within the metric system you just shift the decimal. When we got to the US system, things get a little more complicated, and then we looked at the method of multiplying by 1. Then we looked at temperature. With temperature unit conversions, it's a little different. You're using formulas. You're just plugging in the formula to convert it from Celsius to Fahrenheit or vice versa. We looked at some statistics. These would be descriptive statistics because it's describing. And so we looked at measure of center or measures of center, which include mean, which is another way of saying average, median, which is the middle number, and mode, which is the most frequent. Then we looked at different types of graphs. We looked at tables. We looked at line graphs, bar graphs, and we looked at also pictographs and pie chart or circle graph. Then we looked at the basics of graphs and lines, and we looked at plotting points and graphing lines. And with plotting points, you have an x-coordinate and y-coordinate. X-coordinate always comes first, like x, y, z. And you can use that to kind of see where things line up, and that's where you would plot your point. And then with graphing lines, you build a table, plug in any numbers you want for x, plug in numbers that are convenient, so like 0, 1, 2, or if you know that you're dividing by 2, you would use numbers that are divisible by 2. And then once you plot those points when you're graphing a line, you can then connect dots. That concludes this video. Please like, share, and subscribe. And if you have any questions, put them in the comments below. Thank you, and I hope you have a wonderful day.